Hi, good morning, good afternoon, and good evening based on where you may be coming in from. It's my pleasure to welcome you all to this webinar from GitaCloud. This is Loknath Rao. I'm a principal with GitaCloud, and I will be moderating this webinar. The topic is accurate short-term forecasts enabled by demand sensing with SAP IBP, Integrated Business Planning. As some of you may know, our last webinar on 24th February was focused on multi-stage inventory optimization capability. This webinar deep dives on demand sensing, a key facilitator of accurate demand signals which yield significant benefits when fed into inventory optimization process. Couple of housekeeping items before we jump in. You can send us your questions at any time during this webinar. Use the GoToWebinar chat section to ask a question. We will consolidate all the questions and attempt to answer them towards the end of this webinar. And all attendees' microphones will stay muted for the entire webinar. And this webinar, for information, is being recorded, and the recording will be available after our session is over on our website, and we may also email it to you separately. So we have with us in this webinar our experts Ashutosh Bansal, who is the founder and CEO of GitaCloud. Ashutosh has a vast experience on SAP supply chain products in general. While at SAP Americas, he has spent a long number of years working on a variety of products like advanced planning and optimization, integrated business planning, and several other SAP supply chain technologies. And we also have with us Todd Stenger. Todd is for those of you coming from APO, is a popular person from SAP. He's been the brains behind products like SAP APO, and is currently the solution owner for SAP IBP as well. And Todd has a phenomenal experience in supply chain management spanning across so many years. And with us, we also have Ulka, and Ulka will actually give you a brief actual demo of how SAP demand sensing works. And Ulka is also a strong subject matter expert on supply chain planning products from SAP. And while Ashutosh and Todd will briefly cover the basic business premise behind the demand sensing, Todd will take you through the mechanics of demand sensing in general. The webinar will approximately last for about 55 odd minutes. Maybe we can stretch it a bit more. And then we will wrap this webinar with question and answer sessions. Over to you, Ashutosh.
Okay, thanks, Lok. Welcome everyone to this webinar. This is our pleasure to host you. We know how busy you are, so thanks for taking time from your busy schedule. Before we jump into what demand sensing is and solution demo and everything, I just want to set the stage for why we need something like demand sensing in the first place. When we discuss the need to improve the quality of short-term forecasts with customer executives, we often hear that forecast accuracy is really not an issue, that the demand planners are already achieving 70 to 85% accurate forecasts with their current demand planning processes and tools. We've heard numbers 80 or even 85% forecast accuracy. They sound good, but are they real? We refer to this as the forecast accuracy iceberg. You see the rosy picture at the top that's visible to the executives is really forecast accuracy at a very aggregated level. Think product family, monthly level. It does a good job of hiding all the noise that the supply chain execution layer and demand planners are dealing with. This level of reporting being sent to executives is what we refer to as metrics gaming. It's sort of meaningless from a supply chain perspective. If the supply chain is not producing or shipping product families, and they're definitely not doing them once a month. So there's a lot more to the story if you double click into the details. The SCM manager director already knows that the forecast accuracy drops sharply when you bring it down from this product family level to SKU level and location level. This is the level that the supply chain is really having to ship products to locations that are customer facing And this is where you have to get the level right, or you'll have the right inventory but in all the wrong places, and you'll have lost sales as a result. On the surface, even at this level, the numbers look somewhat respectable. However, when you get down to the demand planner's world of now breaking it out from a monthly to a weekly or a daily cadence and looking at it in a customer specific way to account for different channels and customer segments and so on, this is where you will see the true picture emerge. The forecast accuracy takes a beating at this point, and the ranges are anywhere from 35 to 55% and even lower in some cases. This detail is very important for getting your transportation logistics, getting your inventory replenishment, deployment right, even your production scheduling right. Shipments, if you think about it, happen daily to specific customers. They don't happen weekly for specific products. Your downstream channel partners all have very specific ordering behaviors, and you really need to examine your open order line items from your customers to understand how the short-term customer-specific demand is really behaving differently from your disaggregated forecast. In the traditional demand planning world, usually we end up having some sort of a rough mathematical algorithm approach to disaggregating the number from products to locations and from months to weeks or days. And this kind of evenly spreading things out is where you have all the noise at the level where it really gets executed. People who do not understand this disconnect are always thinking in terms of there is a supply chain plan and the execution guys are just not following the plan, and this is a process discipline problem and so on. You've heard several customers complain about the planning versus execution disconnect. In reality, the execution team in the warehouse and the logistics teams are all reacting to the short-term customer-specific firm demand, which is highly volatile given all the order changes and cancellations that occur, all the inventory issues you may have. And this approach of just disaggregating and expecting the execution layer to fall in line with that is where the forecast versus firm demand disconnects start to materialize and things start to fall apart. Because you don't have the right inventory in the right places, that's per your forecast while you're having to ship per your orders. So think about it this way, customers do not reward you on getting your product forecast right at some kind of aggregated product family monthly level. Yes, they are rewarding you for having your orders filled on time in full 99% of the time. So if you think about what it takes to achieve high customer satisfaction, you will understand that in the short term, having a complete alignment and understanding of what the current demand is and what the demand order placement trends are downstream and what kind of POS data trends you're seeing, so you can better align your inventory and logistics deployment decisions can make a huge difference. So let's just talk about the demand planners world, the business environment that demand planners are dealing with. We talk about consumer behavior. It's evolving all the time. It's showing up in recent news where JCPenney is shutting down 14% of its stores in US. CS is closing down 10%. There are medium-sized retailers that are shutting down pretty much all their stores and going fully online. So you can see the consumer today is buying more and more online. It's buying omni-channel, this order anywhere, pick anywhere world makes it very hard to have channel-oriented, stable sales history patterns for you to understand where the demand will come from. Today's consumer is also fickle. Brand loyalty and sales predictability are words of the past. As market demands move further on the volatility curve, products go viral overnight. One piece of negative news on social media is all it takes to kill an entire new product launch. When we talk about new product introduction, SKU proliferation and churn is increasing with marketing-driven innovation strategies, and companies like Kellogg's that have tried demand sensing have tried it for that very reason, that is just not 4 or 8 or 10 different types of cereals. Now you see hundreds of different types of cereal, and what it does is it fragments your demand in a way that is very hard to understand what an individual product demand is going to look like. When you are looking at new products, the manual estimates of marketing run the risk of making bias in the forecast. You are challenged in terms of using traditional demand planning systems because there's just no history, and the assumption is that sales history is required for traditional demand planning to produce a forecast. Keep in mind also the average life of a product is now 18 months or less. A lot of assumptions demand planning had around having years of history, just that luxury is not available anymore. In fact, if you look at CPG industry in general, 86% of SKUs introduced in the last 5 years are no longer there. Most new products fail to meet their forecasted targets. 33% of new products are gone in the same year as they don't make it. Also, if there are new products that started in the tail, they tend to stay in the tail for life. So it's, although companies keep hoping that the product will come out and become a top runner, usually if it didn't start that way, it's not going to. Because of all these factors, new product error is much higher than your high runners. The bias in the forecast, as people keep hoping for the product to turn around, is also quite high, sometimes almost 3 times higher than existing SKUs. So we have understood the new product challenges. There are also challenges with seasonal items in general. They present a big challenge because you want to get the revenue maximized, but at the same time, you don't want to end up with excess inventory. So it's a balancing act. And when you don't have enough of the history data to create the seasonal profiles, it becomes a challenge. In general, companies, as they have more and more SKU portfolio proliferation, you get a very long tail. If you look at CPG sales, 16% of SKU portfolio accounts for 80% of the sales. That remaining almost 84% of the SKU portfolio still needs to be maintained from an inventory perspective. You still need to provide some kind of a service level to the market. And that's where the error is very high in the tail. It's almost 2 times the top runner's error and almost 5 times the bias. And the tail is just simply too crowded for the demand planner to be able to pay attention to individual SKUs and buffering high forecast error with excess inventory to manage service levels have significant working capital implications. As you can see across long tail, seasonal, NPI, the underlying assumptions of data availability in demand forecasting time series kind of math are now violated. So we no longer have multiple years of history or stable, predictable demand patterns. What this is doing is it's giving what we call forecast accuracy ceiling, where despite the best fine-tuning efforts, throwing different kind of forecast models at it, looking at them, the forecast accuracy is just simply not improving. It's stuck, and it's been stuck for a while. Error, as we talked about it, for seasonal items is almost 50% higher than regular items. It's sometimes crossing 65% error threshold. So high bias, high error. And the idea that planners have to figure this out largely in a planner-centric, manual effort-driven way leads to planner burnout. You get cases of extreme error. And extreme error, we define it as error where forecast is more than 100% off sales in either direction. You could forecast 100 if you end up with actual sales of 50 or less or 200 or more. That's what we call extreme error. Currently, 34% of SKU portfolio has extreme error. 15% of it is on the oversold side, which creates service risk, where you just don't have inventory and you're risking customer set out of shelf availability issues, and 19% of it is on the undersold side, which means you're carrying too much inventory and it creates working capital implications. So the picture we are trying to paint is that given this challenging environment of increased volatility and shorter life cycles and higher number of SKUs to deal with, the traditional demand planning solutions and tools are just not adequate anymore. They need to be supplemented with newer math around pattern recognition, demand sensing, at least for the next 4, 6, 8, 10 weeks, which is the important gray zone between supply chain medium-term planning and execution, where you have to get things right. What is needed in terms of enabling this is a demand-driven value network that can sense and react in near real time. And this includes both the ability to sense true demand. So when you've had stock outs at retail store level, you still want to know what that true demand would have been had there been. Inventory for POS sometimes doesn't really give you a reflection of true demand. And once you've understood what that true demand is from a demand sensing point of view, you need demand shaping capabilities to make sure whether that's through promotions, through NPI, through market advertising, whatever else, that you're able to shape that demand. Our sense is that right now people are not fully utilizing demand sensing systems. They're just largely internal. They're not fully based on, along with POS, all the other data sets, the customer confidence, the weather patterns, everything else. And from the shaping side also, I think mostly it's just demand translation that is occurring, demand shifting that is occurring to say move something out by introducing a promotion later when we don't have enough inventory in the short term. But it's not really enabling a higher revenue and profitability curve. And this is what the new demand-driven value networks are all about, providing a profitable response to this volatile demand. So with that, I'd like to pass it to Todd for an overview of the demand IBP module. Todd, go ahead.
Great. Thanks, Ashutosh. We'll take just a second here to get my screen up. Okay. We should be seeing, Ashutosh, are you seeing my screen now?
Yes, I am.
Okay, great.
Fine.
So we'll take this a little bit more to a product focus now. Ashutosh has talked a lot about some of the different themes and business drivers. Just as a quick level set, we have SAP Integrated Business Planning as our supply chain planning platform in the cloud. And if you've been on some of the other webinars that Ashutosh and Lok talked about from GitaCloud, you've seen some of these things, but these are all the different areas of IBP. So we have the Supply Chain Control Tower, which is about visibility, monitoring, alerting, IBP for sales operations, which is strategic, tactical decision process, and then we have more of the operational pieces, which are IBP for demand, IBP for inventory, and IBP for response and supply. So today, for the context of demand sensing, we'll be talking about IBP for demand, but we just want to level set this for where we are. If we look at IBP for demand, there are two main areas that we're working on. One is we want to do more accurate midterm statistical forecasting, but we also want to react to the short-term demand changes, and those are some of the things that Ashutosh was talking about. I want to see, as things are happening, I want to react to those changes in demand. I also want to be able to collaborate within my demand planning process, and then all of this is really to drive that more accurate deployment of product based on that short-term demand. And Ashutosh talked about that a little bit, of the right product in the right place. And so part of that is really the demand sensing piece of that. If you think about a little bit about the pyramid that Ashutosh showed, which is, at the high level, I might have fairly good forecast accuracy, but as I get down into more detailed levels, I'm going to be not at as high of a level of accuracy. A lot of times we have high-level things in our S&OP process, macroeconomic indicators, marketing input, and that's really more of an S&OP thing. And as I get down into the more detailed, all the way down into the short-term demand sensing, I start working with order patterns and very short-term trends that I want to pick up in the demand sensing, right? And so there's a continuity of this that goes from an aggregated plan at an S&OP level to a very detailed plan and daily buckets in the short term. If we think about this of sort of demand planning versus demand sensing, the idea is that in demand planning, I'm doing time series, historical based, trend and seasonal patterns, whereas demand sensing, I'm trying to adjust that demand plan, that longer term demand plan, using very recent and present data, and I'm using pattern recognition algorithms. And you can see on the chart here that I might have a long-term demand plan that's going out for a year, and then what I'm doing is on a very near-term basis, I'm running demand sensing, which is usually daily buckets for maybe 4 to 6 weeks out. and I'm getting a new demand plan, so to speak, every day. And then the other thing that we want to look at is we want to see how is that adjusting, right? So like in weeks 4, 5, and 6, I might be picking up a short-term trend in a sales of a product that I have, and I want to identify that in demand sensing, and then I want to start alerting based on that, right? So where that sense demand is deviating from my longer-term demand plan, I want to alert the demand planners to that. They may need to make some adjustments to the longer-term plan, or there might be some short-term things that they say, that's not really part of it. This was going to come back. But we want people to be able to look at that and understand those differences. If we look at sort of a chart of the differences here, basically we've got a fundamental different principle in the statistical forecasting versus pattern recognition for stat forecasting and demand sensing. We also have a very different planning horizon, which I kind of showed on that graph, which is, for demand sensing from an SAP perspective, we're looking at very short term, up to 6 weeks or so. And we're doing this either weekly or daily on the demand sensing side of things. If we look at the data we're using, in statistical forecasting, we're looking at just our sales history. We're looking at seasonality, trend over that longer term horizon. We're picking those up. And in the demand sensing, we're looking at short-term patterns over the last year maybe, and we're looking at seasonality and trend really coming from the consensus forecast. I'll talk a little bit about how we do that. If we look at our algorithm of what we do 2 major things when we're doing the calculations, right? And this is a sort of a high-level thing. So we take into account open orders that you have in your system as well as your historical sales. And then we're going to take that that longer-term forecast. We're going to adjust it on a weekly bucketed basis. We look at bias tracking. So Ashutosh talked a little bit about bias and the high level of bias in a lot of consumer products forecasting. So we identify what that bias is, and we want to adjust for the bias a little bit in the demand sensing. And then we have something that I don't love this term, but it's for lack of a better term. We look at the open orders and we look at how those are going to be consumed. And this is the idea of saying, if I have a customer that orders every Friday, and over time, or a group of customers that tend to order, and I get an order to be shipped out every Friday, and then I see an order from that group on Monday, the system tries to determine, is that really just the Friday order pushed out to Monday or pulled into Monday, or is that a new order that I need to take into account with my forecast, right? So an increasing sales quantity. So we look at that as well. And then we take that and we blow it down to daily level. So we do this, we look at the long-term forecast patterns, and then we look at shipment patterns in history, and then we split it out to daily buckets. All of this comes out with a daily level forecast for 4 to 6 weeks, give or take. And then we blend this by lag, right? So we look at things of, if I get an order, how far out do I ship it? So we do some lag analysis as well. We can also do bias and variability calculations as part of this, right? And so those tend to be things that would feed bias, starts letting you know which products I have high level of positive or negative bias. And the variability calculations can then also be used in downstream processes like inventory optimization. We get the question oftentimes, well, you keep talking about 4 to 6 weeks, what can I really impact in that, right? And oftentimes people talk about, well, I have a 4 to 6 week, I have a 4-week frozen horizon for all my manufacturing. If that's the case, then you're right. That's probably not going to have a huge impact on your production scheduling. But if I look at this and think of what processes I can impact, in the near term, clearly deployment and transportation decisions are impacted by a daily level forecast in the near term. If you get to start maybe this slushy period of 5 to 6 weeks, oftentimes you can start looking at production packaging sequences. And for some industries and so based on their lead times, even at 5 to 6 weeks, I could be doing material purchasing decisions, right? And all of this again is driven by doing this, looking at the detailed information out on a daily level, so I can determine exactly where I need to deploy product. Just from an example of kind of how this effect can happen, if I have a forecast of 40 units nationally, There's a couple different ways I can do this. One is that I might do a national forecast and just split it equally to among my DCs. I might be doing a DC level forecast, which oftentimes is best practice. But either way, if I end up with roughly 40 units of demand within this national area, if I do this and I take my demand, my weekly bucket of demand, and say, let's say these are the same, they're 20 in each, and I say, what would I actually replenish to for my East and West DC? If I split that demand just across the week evenly, I get 4 units each day I'm going to ship from my national DC to my East and my West DC. But there's a what if here. And the what if says, what if my pattern within a week is different between the East and the West DC? So what if the East DC is very front-loaded in the week? So I need to ship out to my customers from the East DC. Monday and Tuesday are the biggest days. It tails off towards the end of the week. And conversely, the West DC, I don't get a lot of orders to ship Monday and Tuesday. A lot of people want things shipped out Thursday and Friday for whatever reasons. Right, so these are the types of patterns that we're trying to identify using demand sensing and the pattern recognition algorithms that we have. The result of this is that I really get the real sales trends picked up, and I update the short-term forecast. And now if I were running deployment and saying, what do I need to deploy out, I'm going to deploy a lot more to the East DC in the beginning of the week, and I'll send less to the West DC. And if we look at this from just an inventory perspective, if I had gone with my standard 4, 4, 4, 4, 4, 4 across the week, I would have sent more things to the West DC that I didn't need. So I risk potentially, depending on how lean my inventories are, I risk shorting on the East DC, and I'd be sitting on inventory in the West DC. And even if I take into account that I wouldn't necessarily be shorting in the East DC, you can see that this is going to have an impact on my overall inventory numbers just by having the right product sent out at the right time to the right DC. So I've got just some very distinct effects that I can get out of demand sensing. Again, this is a very simple example, but it shows the power of understanding that daily demand. If we look at kind of from a process perspective how this works, really we have our algorithm in the middle, right, demand sensing, that we can run. We're taking into account the consensus demand plan, and again, part of the goal of using that consensus demand plan or your long-term statistical demand plan is to pick up things like trends and seasonality, and also any kind of macro things I need to know. Customer is building, one of our big customers is expanding significantly. Things that math has a hard time understanding or predicting. And then we take into account the shipments. So what have I actually sent? What sales orders do I have? This is going to vary by industry, but I might have open orders in my system for 2 weeks out in the future, right? So what orders do I have there, and does that match up with what the forecast was? I can also bring in trade promotion uplifts. So this would be from potentially a trade promotion management system if you're in a consumer-focused industry or highly promotional industry. You could bring in other information if you're in maybe not as promoted industry. And then down the road, we are also, towards the end of this year, we should have a tie-in for point-of-sale data that can come in. So again, consumer industry, that they're looking at what is selling downstream. I can bring that in as well and look at that. And that's really where the lag analysis that I talked about comes in, right? Because a spike in point-of-sale data this week, depending on your supply chain, might affect you, or your customer supply chain might affect you next week or the week after, right? So we have to look at how long will it be until you see those orders. So all of this gets brought into the algorithm, processed, and then we get the daily sense demand plan out of it. If we look at what impacts you can have, so this is a case study we did with a global health and beauty care consumer products company, and they are using our demand sensing algorithms. But if you look at this, there's a couple things I want to point out. The overall, this is by lag, so 1 week out forecast, week 2, week 4, and week 6 that we're looking at, and you can see that their error that they had, their forecast error that they had in using a weighted MAPE in those weeks using their standard long-term forecasting, and then you can see what we had, what we did with demand sensing, right? So we saw a 49% improvement in week 1. 26 in week 2, 20% in week 4, and 18% in week 6. So they're fairly big numbers that we're getting. The other thing that we found was that they identified forecast bias, and they had a 6 to 8% reduction in forecast bias across the 6 weeks. And then what they found was the driver of this was they had a significant over forecasting bias. This company was a 7 to 8 day or average order lead time. So really, you know, they probably had a fair amount of their orders in week 1, which is why you get a huge bump up in the forecast, and then it tails off a little bit. But again, when you look at these, you know, an absolute difference on my, you know, my error measure of 30 points is pretty big that we can get. So there's definitely value in here. We've definitely seen customers that are getting lots of value. So with that, I'm going to hand it over to Ulka to take you through a little bit of the system, see what it looks like, and describe a few things for you.
Thanks, Todd. You made the complex topic of demand sensing easy to understand. Hello everyone, this is Ulka Rathi, and thank you for your interest in demand sensing. I will be happy to walk you through the demand sensing application. I'm going to show it in 3 parts: Excel UI, configuration, and dashboard. Now let me orient you with the Excel UI that is used to access data in IBP. The rightmost part and the upper hand side shows the graphs. This graphs comes from the figures, the key figures selected on this side. On the left hand side at the bottom, it shows the key figures, various key figures used in the demand sensing application calculation. And on the rightmost side at the bottom, it shows the data in the time series basis. So this is how it looks. So as Todd explained, the input to the demand sensing are sales and shipment data coming from SAP ERP and demand planning data such as consensus demand. Demand sensing refines the demand planning forecast based on current order and shipment data coming from SAP ERP. So the main input key figures are consensus demand. This consensus demand is the final output from the demand planning process, which could be hosted in the IBP demand or SAP APO demand planning model, or loaded from an external system. Requested quantity demand comes in terms of the sales order quantity. The confirmed quantity is again the confirmed sales order quantity. The sensed demand quantity is the output of the demand sensing algorithm, and this key figure stores the result of the demand sensing. Since demand quantity adjusted is used by the demand planner to override the sense demand calculation by the system to accommodate the market intelligence not available to the algorithm. So basically here demand planner has the upper hand, and he can dictate the value for the demand planning. Final sense demand quantity is the final output taken to downstream process like inventory optimization and supply review. It combines any edits from demand planner along with the output from the demand sensing algorithm. So basically we are considering the main key figures of consensus demand, requested quantity, confirmed quantity, sense demand quantity adjusted, and sense demand quantity final for this data set purpose. Here you won't find the shipment data. For the purpose of simplicity, this has been omitted. Now let's run the statistical forecast or the demand sensing algorithm. It has to run on daily basis. The forecast model to be used will be demand sensing. For the larger chunk of data, it might take a little bit of time. Here the data chunk is a little smaller. So it should finish it in a moment. Here is how we can see the status of the run of the demand sensor. The purpose of this run is to get the calculated data of the sensed demand from the demand sensing algorithm. This run is completed. So now let's go to the current week where it is showing us the calculated result by the demand sensing algorithm. Now week 12 is the current week. Now you see that the sales demand quantity has been populated. Now I'm going to override this figure of the sales demand quantity adjusted by some other figure. Let's say so now we will see that based on the changes in the sales demand quantity adjusted by the planner, the final quantity for the sales demand has been calculated to somewhat 3,899. Likewise, the calculation has been performed on the data side and we get the final sales demand. So this is the part of the Excel UI which planner has to do on the daily basis. Now let's move on to the part of the configuration where we can see the demand sensing configuration by means of forecast model and the algorithm setup. The demand planner can set the forecast models from here. He has to select, he or she has to select the manage forecast model from the view here. Now there are two types of two models for demand sensing full and demand sensing update. The key difference between full and update is that update only refreshes the sales order data from SAP ERP system. It does not re-optimize the parameters as is the case with the full run. We recommend that full run to be executed on Monday followed by update runs for the rest of the week. So let's look at this demand sensing full. On the general tab, there are a few mandatory parameters setting. The model name and the time setting, periodicity, historical periods and forecast periods. The periodicity mandatory setting needs to be set to daily for the demand sensing algorithm. The periods are entered in days when periodicity is set to daily. Historic periods, we recommend that it needs to be a 52 weeks, and so that the demand sensing algorithm shows the good result. So 52 weeks has been converted to the days based on the calculation of work days as well as some other parameter has been considered here. Forecast periods are usually business case dependent. Demand sensing is usually used in forecasting range of 4 to 6 weeks. Here we have taken 6 weeks. So there are no pre-processing steps for the demand sensing algorithm. And in the forecasting steps, if you see the algorithms added in the forecasting steps is demand sensing full. So the overall parameters are main input for demand sensing step is requested quantity, which is nothing but the sales order requested quantity. The target key figure for the forecast is sense demand quantity, which we have seen it in the Excel UI. We can consider the product lifecycle information if the product is new. Now let's move on to the details of the demand sensing algorithm. The consensus forecast parameter shows which key figure will be treated as consensus forecast in this algorithm. Here we have selected consensus demand without promotion. Here you can see there is a list of, quite a big list of the key figures which you can treat as a consensus forecast for the algorithm to calculate. Now the bias horizon is in weeks. Actually the weeks in past for which historical bias is calculated and used in the forecast bias optimization. The default values are 1, 2, 4, 6, 8 and 9, which means that the forecast bias is calculated for 1, 2, 4 and 6, 8 and 9 weeks ago. Specifying the bias horizon is mandatory. Make sure that you enter the values in ascending order. Now this is the maximum forecast increase, minimum forecast increase, maximum forecast increase and decrease are the bias adjustment threshold settings. We can cap the amount of changes demand sensing engine is allowed to make up or down in terms of absolute or percentage changes. Now let me take you through an example to understand this fully. Here in this example, the maximum percentage increase is set to 20%, maximum increase volume is set to 500%, maximum percentage decrease is set to 30%, maximum decrease volume is set to 300 quantity. So the data for week 0 to week 5 has been given. So let's see for week 0, the input consensus forecast is calculated as 1500, which is coming from the demand planning. The bias impact has been calculated as negative 40%. And consensus forecast is, the adjusted consensus forecast is 1500 plus 40% will be 2100. But the maximum allowed forecast is, the capped allowed forecast is only 300, only 20%, which comes to 1500 plus 300, which is 1800. So we can see that here clearly the result of the capping of this percentage given over here, which will cap the any adjustment done on the consensus forecast or the adjusted demand quantity. On the week 1, the consensus forecast given is 3000. It has a negative bias impact of 20%. Planner has been adjusted this forecast to 3600, but the maximum increase volume allowed is 500. So the resulting figure will be 3000 plus 500 will be 3500. Now week 2 and 3 are absolutely within the range of any changes, so there are no changes. Week 4 is having the consensus forecast of 2000. Calculated bias impact is positive 40%. Demand planner has been adjusted to 1200. So the capped adjusted forecast sense forecast is as per the decrease in threshold is nothing but the 300 units. So 2000 minus 300 will come to 1700 units. So likewise, similarly, it has been calculated for week 5. So once this is clear, we know that this threshold has a very important value, importance in calculation of the final demand, final consensus demand. So this needs to be set very carefully. Now let's move on to the remaining parameter of the algorithm. The future ordered quantity is the key figure representing the confirmed and unconfirmed quantities in sales order and stock transport orders that are due to delivered in the future. The quantity ratio calculation horizon is the period for which the system is to calculate the rolling average ratio of quantity of products already delivered to the quantity of products for which orders are still open. Historical order quantity is the key figure representing the confirmed and unconfirmed quantities that were not delivered by the requested date in the past. Delivered quantity is the key figure representing the quantity delivered in specified period. The daily average calculation horizon is the number of weeks in the past for which the delivered quantity is averaged for each day in the week. This is used to split weekly forecast data down to daily values. Minimum data point is the number of historical data that are required for demand sensing runs. The default value for this setting is 15. So at least minimum 15 values are required to run the demand sensing algorithm. The baseline threshold is the most important parameter. The baseline threshold used by the system to check the accuracy of the consensus forecast before demand sensing is run. If the calculated weighted mean average percentage error is smaller than the baseline threshold, the system does not perform the optimization step that are parts of the demand sensing process otherwise. The default value for this setting is close to 37%. Select work days. These are the days of the calendar week that the system is to consider as work days. The system disaggregates the weekly consensus forecast into daily forecast based on the days you select here using the daily average calculation setting, which I mentioned earlier. Of course, note that you must select at least one workday for this setting. And this we have looked at the overall parameters of the algorithm. So now we have so far seen the Excel UI where the calculations are performed, the algorithm using which the calculations are performed. Now let's move on to the part of the dashboard which is used for the analytics purpose, as well as the demand planner can use it for making the corrective decisions or corrective actions. On the dashboard screen, we have to select the particular dashboard used for the demand planner. I'm choosing here the demand sensing. Normally this setting comes as a preset for any user profile. Click on the role of demand planner. The first graph will show you the sense demand forecast error. Now for product GT001, the sense demand forecast error is 12.81%. For GT002, the sense demand forecast error is 15.86%. And GT003 is 17.97%. Now for GT004, the demand forecast error is more than 20%. Here the planner can make a decision as which of the demand sense forecast error is beyond which needs to be corrected. So let's say if the planner thinks that anything beyond and above 20% needs to be corrected, he can go into the planning parameters and set the adjusted demand forecast quantity to the appropriate level so that the demand forecast can be reduced. So here are the statistical forecaster. These graphs are just indicative that usually the sense demand forecast error are much more accurate than the demand planner or the statistical forecaster comes from the demand planning models. Now in the third chart, you will see that there is consensus demand in blue and sense demand quantity in orange. The consensus demand quantity looks like it has the high bias versus the sense demand quantity. So sense demand quantity or the demand sensing algorithms are tapping the higher bias which is coming from the demand plan, and it is helping out to reduce the targeted inventory stocks or the target inventory figures. In the sense demand forecast, the fourth chart will show you the sense demand forecast error lag 1 week versus lag 3 weeks. The sense demand forecast error for 1 week is lower since it's taking into account the very recent figure or key figure changes such as key figures or the delivery quantity key figures than the sense demand forecast error for 3 weeks. So the daily run of the demand sensing is advised. To recap, we have seen how demand sensing works in the Excel environment, what are the input key figures, output key figures, how to run demand sensing, and which are main parameters of the demand sensing configuration, and how to set those. And finally, how to use the data to analyze using the dashboards and take the corrective actions. Thank you all for your attention. Handing it over to Ashutosh.
In terms of demand sensing benefits, as you can clearly see, the benefits accrue to the entire supply chain, not just to the demand function. As you have less short-term demand forecast volatility, it obviously improves the inventory deployment decisions and helps the demand planners free up from the firefighting mode so they can focus on the medium long-term forecasting processes and start becoming more the market intelligence managers, making sure they connect with sales, marketing, finance and others to really bake in the best quality forecast in the medium term and let the engine in the short term refine using demand sensing algorithm. In terms of, and I'm not going to read all of these, but just so you have an understanding, right from inventory optimization to improved scheduling from a manufacturer supplier perspective to improved order fill rates in logistics and distribution, that the value and benefits are pretty pervasive across the organization. We've talked so far in the context of CPG and retail, but we just wanted to make sure that you understand that demand sensing can be applied to all high volatility demand environments, not just to CPG and retail. Obviously, that's where inventory to revenue ratios are high. That's where demand volatility is high, and they were the natural sort of pioneers in demand sensing space, starting from early 2000s till now. But there is a lot of focus and attention from other industries, whether that's consumer electronics, chemical, pharmaceutical, automotive, and so on. So we have customers that are trying to apply this sort of concepts to auto spares forecasting, for example, and pharmaceutical drugs that go out to distributors and so on. So there's just a lot of use cases across many industries. The key message I want to leave you with is SAP IBP is the platform of choice for demand sensing, and especially because demand sensing improves forecast accuracy, but by itself, that's just a pretty number. What really happens when you combine inventory optimization with it is you get to operationalize the benefits of that accurate forecast in terms of optimal inventories across your entire supply chain, right from customer-facing nodes to internal nodes and all of that. And as orders come in different from the forecast, the response management function makes sure that you will be able to service your best customers and your location-oriented decisions, just making sure that OTF metrics are high. All of it, as you can imagine, requires a very integrated, high-speed, high-memory-based architecture, which is SAP Integrated Business Planning on HANA, with the robust integration out of the box with ECC or S/4HANA. You also get the benefit of always having real-time, near real-time demand and supply pictures represented. So these processes of demand sensing, inventory optimization, response management are always working and running with the latest information. So this is a key reason why some of the best of breed providers, they just have either this level of functional coverage end-to-end or the integration or the high memory features, and this is what makes IBP the platform of choice. So you understood the value proposition. We have been conducting several webinars. Lok mentioned some of them earlier. We would leave this tech and recording behind with people who attended, and you can, using the links here, listen to previous webinars, SNOP or inventory optimization if you missed them. Just also, you understand what we are doing in terms of upcoming events. We have an SAP IBP SNOP workshop coming up this weekend. This is a 4-day hands-on detailed practitioner's view over this weekend and next weekend. There's a link to register here if you're interested, or you can reach out to us afterwards. We are also doing a customer event in Mumbai in India. This is targeted at supply chain executives, VP supply chains, or CIOs or higher. We are going to have SAP India's head for S4HANA, Neeraj Athage, as a keynote speaker. He'll talk about digital business strategy. We'll provide a full overview and showcase case studies, etc., for executives in this event. We are also coming up with a demand and inventory workshop in April 29th timeframe. This workshop will be focused on IBP demand and IBP inventory applications. So for folks who are interested in learning and deep diving in IBP demand sensing and inventory optimization topics, you probably want to make a note of that. With that, I'd like to open the floor for Q&A. Let me see if there are any questions in the chat. Otherwise, just feel free to type in any questions. Okay, so let's look at some questions here. And I'm going to read this out. The demand sensing consumption logic cannot be applied to a retail environment. Do you have any other demand sensing tools that deal with retail demand? Todd, do you want to take that?
Sure. We have a couple different things in the retail space. So we have another supply chain planning tool. It's an on-premise tool called SAP Forecasting Replenishment. Certainly around things like fresh food products, grocery, convenience stores, some of the very fast-moving consumer goods in retail. So we have a bunch of tools in that to do forecasting. We've just expanded that to include our unified demand forecasting tool, which takes into account multiple demand influencing factors. So at a retail store level, those are really the tools that we would generally see being used. And then demand sensing is really meant to be used at a more of a warehouse level or a from a more of a manufacturer's viewpoint in the retail supply chain.
Great, thank you. Another question, Todd, is what's the roadmap for IBP demand look like in terms of being able to plan with POS data and POS data integration?
Yeah, the point of sale data integration should be coming out later this year. I think in either the 1708 release or 1711, which would be August or November correspondingly. So that should be there this year. And then our roadmap for the increasing the demand sensing capabilities is to, once we have the point of sale data, we want to open things up to any demand sensing, any demand stream that you want to bring in. And then the other thing we do is when you do that is we start calculating a contribution margin for each of those demand streams so you can see which ones make sense. Point of sale is the first one that we'll get this year, and then sometime next year or possibly outside of that, I'm not sure how much effort there is to open that up to any additional demand stream that you want to bring in.
Okay, great. Todd, another question I have is what kind of data do customers need to have before they can start a demand sensing project?
Sure, the data is actually fairly straightforward, and it's pretty much the internal ones that you saw. The internal signals are ones that almost everybody has, right? So you need your historical sales. You need to bring over your open orders that you have in the system. You need your long-term forecast. And those are really the only things that you need to get started, right? We also do some things to, there are some more technical things where we use your historical forecast, and we do snapshots of every weekly forecast for the past 52 weeks. You don't need those to start though. So if you're not tracking that, if you don't have, basically snapshots of your forecast for, in weekly buckets for the past year, we have some techniques for sort of estimating that to get started. And then, so if you, like I said, if you don't have that, we can estimate that and do some things to fill in some gaps for you, and then the system will learn over time as you start taking those snapshots and everything. But the fundamental data really is just your your consensus forecast or your long-term forecast that you have today, and then pull in your historical shipments as well as your open orders and historical orders. So those are things that generally we all have, and they're easy to get.
Wonderful. Todd, the next one is, this is someone who's saying, I work for a CPG home and personal care firm, and we are not allowed to change forecasts within the 13-week firm period in my company. How can I educate them on using demand sensing?
So this is an interesting case, right? Is that this is very true of a lot of CPG companies, is that they say, well, we've got a 30-day frozen period for manufacturing, so we're not going to change the forecast. Which I understand, but the fallacy of that is that there are things when you're deploying product out and other things where you do need to, where updating that forecast is probably a good thing. The other thing is that we find that almost always a frozen horizon for manufacturing just means I don't want the planning system to change it, but companies still react and still do some firefighting. They still do change their manufacturing. So we find that although people say they're not changing their forecast, they're reacting to orders and things, and they're actually adjusting their manufacturing schedule, commensurately. The other thing is that when you look at who actually uses this data, right? So the demand planners are generally measured on that, that 1 month lag that they're trying to be accurate on, right? And that's good. Demand sensing generally doesn't change that. So companies that put in demand sensing, usually it's not the demand planners that are measured on the demand sensing piece inside of that 4-week horizon. So we do update that, but it tends to flow right into the supply planners. One of the reasons why we have the alerting for where there's a deviation between what the demand forecast was and the demand sensing, there's 2 reasons. One is because we want the demand planners to be able to take into account outside of that 4-week horizon that they're not allowed to change. The other thing is that when the demand sensing tends to change numbers, the supply planners, the first call they make is generally to the demand planner to ask them what's going on. Right, and so we want the demand planner to know that things have changed and that there's something they may need to look into. There's also an organizational change that may take into account, right? So today you're not allowed to change that, but if you put in demand sensing and there's benefit to be had, your overall thing says, hey, we are going to update this inside of the 30 days, but we're not going to penalize or reward the demand planners who are working outside of that horizon.
Okay, great. That was great, Todd. I think that's all the time we have today. We've gone 4 minutes above, so we just would like to give it to Luke for him to wrap this up.
Yeah, thanks, Ashutosh, Todd, and Ulka for patiently taking everybody through this session. I hope the attendees have appreciated this event. And as Ashutosh has mentioned, there are a series of events planned in the future, including workshops and customer events. If you're interested, you can reach out to Ashutosh at these numbers, which are mentioned on this slide. So it's a number in the United States, but you can always write to connect@GitaCloud.com, and one of us will definitely respond. And if you have any additional questions around this area of demand sensing or even IBP in general, please do write us, and we may take our time to respond, but we will try our best to respond as early as we can. And do visit our YouTube channel to familiarize yourself, if you need to, on IBP in general and the various functionalities of IBP. We will have our next webinars coming up on other topics, and we will announce it again. Thank you very much for attending this webinar once again. And good night and good day, depending on where you're based. Appreciate your presence. Appreciate your time. Thank you.